overflows. In this chapter, we're going to be looking at buffer overflows defined, overflow illustrations, secure code review process, and general prevention techniques. When you think of buffer overflows, basically a buffer overflow is a condition that exists when a program attempts to put more data in a buffer than it can hold, or when a program attempts to put data in a memory area past the buffer. In this case, a buffer is a sequential section of memory allocated to contain anything from a character string to an array of integers, basically numbers. Writing outside of these bounds of a block or of allocated memory can corrupt data, crash a program, or even cause the execution of malicious code. Many people know that buffer overflows take place when too much data is accepted as an input value, which in turn writes over specific memory segments. A buffer can be overflowed with too much data, but for it to be of any use to the attacker, the code that is inserted into that buffer must be of a necessary length, followed by commands the attacker wants to be executed. So if the buffer overflow can take place where arbitrary data is shoved into various memory segments, or carefully crafted set of data that can be pushed in that will accomplish a specific task, like giving an attacker an open command shell with administrative privileges. Now if we take a deeper look at how this is accomplished, when software is written to accept data, which can come from a user, website, database, or another application, something needs to happen to this data. It has to be inputted for some type of manipulation or calculation, or it will be used as a parameter to be passed to a procedure. This procedure is the code that will carry out the necessary functions on the data and return the result back to the requesting software. When a programmer writes a piece of software that will accept data, the variable has to be constructed to hold it. And this variable and the data within it needs to have a place to reside in memory. The program must allocate this memory space, which is referred to as a buffer. And a buffer is a contiguous segment of memory that holds several instances of the same type of data. You can think of a buffer as a small bucket to hold water, a variable that holds data. We have several of these small buckets stacked on top of one another, which is basically a memory stack. As an example, in 1996, the European Space Agency's Ariane 5 rocket exploded right after launch because of a program trying to put 64-bit number into a 16-bit memory space, which simply would not fit. Now with overflow illustration, as you can see in this sketch, we're trying to write 10 bytes of data into A, which there's not enough room. There's simply only 8 bytes available, so you cannot shove 10 bytes into an 8-byte space. So because of that, it had to continue forward and actually end up changing B unintentionally. Buffer overflows is one of the biggest security risks we've ever seen, and you can look back in time and see instances of buffer overflows, and to this day you can still see many instances of buffer overflows. And with this, it's a pretty simple concept, but essentially the stack of a program stores the data in the order where the parameters are passed to the function are stored first, and then the return address, and then from there the previous task stack and pointer subsequently affect the local variables, and the variables may get passed without any sort of checking of the boundaries. In other words, what's the size, what can it accommodate? So if there are no boundary checks, then we find ourselves potentially corrupting the stack because we're going beyond the allowable space. And if a hacker does this in a crafty kind of way, they could actually point it to some other programming code that they wish to execute. Now, understanding memory organization, we have to realize that a process running in memory has substructures. With these substructures, we have code. Code is a read-only segment that contains compiled executable code of your program, your computer program you're trying to run. Data is a writable segment containing static, global, or initialized or uninitialized data segments and variables. These last two are pretty important. When you look at the following PowerPoint slides, you'll see them discuss stack as well as heap. Stack is a data structure based on a last in, first out ordering. Items are pushed and pulled from the top of the stack, and there's a stack pointer, which is a register which points to the top of the stack most of the time. The heap is essentially just the rest of the memory space that ends up being assigned to the process. So you're going to see in these following slides stack and heap in use. How buffers and stacks are supposed to work, the way it was designed to work. As you can see, you have the input into the application. We have the variables that hold information, the return pointer, and of course you can see 5, 4, 3, 2, 1, and then 1, 2, 3, 4, 5, and it goes to the procedure, and then of course back to the application through the variables and the return pointer. Here they're going to show an example of the stack and the heap entries used for a simple program. A user is going to enter in a username and a password, then upload a file and write a description. So it's showing Windows here. See the stack and the return address, and the pointer code and the buffer information. You can see the heap as well as the stack. Username and password information passed over and held in a buffer. Okay. There's the upload of the file, held as well in a buffer. And finally, the write of a description. So it's showing how it's supposed to work when we're using, putting in information and we're using a software program. Return control to parent program. It actually executes the code that the return address points to. Now, as far as a buffer overflow, which was nothing we really wanted to happen, with this, they're kind of showing that we could have malicious input. And sometimes buffer overflows occur not due to malicious input. It's just something that was not actually tested well with the program, where simply too much information was inserted and it was not able to hold it in the buffer. So with this, if we were actually intentionally doing this, to overflow the buffer, we'd have to calculate the entry point of the program and figure out how much data, we could input where we could actually overwrite that return address, which would basically could mess up what the program was designed to do. And realize that this return address tells the operating system where to go to execute the code. So that's a really critical part. If it's been overwritten with malicious data, it could point somewhere else. So that's not what was the intention that we had whatsoever. And then if you are a hacker and this was very well planned out, you could execute the injected code and exploit the machine. Now, buffer overflows do occur sometimes simply by accident. It's not always intentional from some malicious hacker. Just let it go through the sequence again. So it could be malicious code that's designed to do this. Just simply putting in too much information. And therefore, they've altered it. Returns control to the code that the return address points to, the address that the hacker has changed. So we got to start thinking of what we can do as far as countermeasures. Is there anything we can do to prevent this? One more thing before I do that, though. This is just a quick example. It's just a little storyline, hackersvoice.com here, or .net rather. And the main thing here with this is back in October 2000, there were hundreds of flights that were grounded or delayed because of an air traffic control system. What it really came down to is they typed in too many characters. Simple as that. Typed in 9 instead of 5 characters into a flight description field. All right, and it created a computer glitch and really messed things up. This is aviation, so it's kind of an interesting story, but a true story. Okay. Now, we wish to prevent these type of things from happening. So what is a security code review? It would be nice if we could go and do a security code review, process in which the code is reviewed for flaws that could compromise the confidentiality, integrity, or like we saw with the air traffic control in LAX airport there, the availability. Okay, so the thinking is we should try to review our code before it's put into production, try to catch as many problems as possible, again, before it's put into production. We should educate our people who are writing the code to think about security and do these reviews, and of course strengthen our knowledge of the application. We need to think about the vulnerabilities, the risk, when we're going to conduct this code review, who's going to be involved with it, what are we going to look for, how are we going to fix the issues, maybe we could use automated tools. So we're trying to look for the possibilities, look for security vulnerabilities that we may have. And how do we do this? They say attend training, read, try to learn as much as we can so we're aware of what some of these vulnerabilities may be. And you could put together some people with less experience with people with more experience, and it would be very educational there, help us with our practice. Know the business risk. We have to think about what would happen if we do not protect our information, if we do not review our code, and this code exposes us to great vulnerabilities. Review user cases, do different types of users take different paths, do a walkthrough at the code level, when to conduct the code review. A lot of people, I think you will hear, come back and say, we don't have time. We have big time constraints. We just can't do this. We're a busy company. We've got to just get on with things. What we have to realize, though, is when we fix security issues after deployment, a lot of times is going to cost us more in the long run and be more time consuming than if we would have dealt with it early on. The idea is to not be delayed in our reaction. We like to think about the problems, look at the possibilities, and try to be proactive with security, not reactive with security. So we have to ask yourself a lot of questions. I mean, what's going to happen if we are insecure and we don't really review our code and we do have some great vulnerabilities, or a lack of availability like with the air traffic control example? And we ask ourselves a lot of questions. What components have the largest attack surface? What components protect the most important data? And of course, these could all have issues. There's a database side. Do we have encryption, session management? What's the most important to our company? When to conduct the code review again? Will time allow it? We have to basically make time for this. It's always better to find your problems early on in the process, not after it's deployed and you go, oh my goodness, what have we done? This code is not secure. Sometimes we hear on television about websites that really weren't ready. Maybe they didn't have their code secured. They didn't have their networking secured. And it's best to do some sort of review rather than no review at all. So who gets involved in the secure code review? Developers, yes, definitely. Knowing the architecture has advantages, and they should definitely communicate. Who are your strong developers? Pair them up with the new developers, the junior developers. Developers with security knowledge, that would be great. Understanding secure coding. Sometimes you have people that were taught the way I think programmers were taught for years and years, that simply get the program done, make it function. Security, well, we'll get to that later. I think it's changing. I know when I went through schooling, and many people I speak to, they mentioned that security was never ever taught to them. When they were learning to program, it was simply how to use the programming language and get the job done. And truthfully, I think a lot of programmers are pushed to get the program completed, even if it's really not ready. Sometimes I think we're beta testing a lot of people's software, because really security was not necessarily built into it, and nor do they take enough time to get it to where it needs to be. So as part of your secure code review, what to look for? Configuration. Configuration files can have default settings that have well-known security flaws. There could be sensitive information that could be revealed in these configuration files. such as database usernames, passwords, test IDs. So of course we would try to, deal with this. What to look for? Authentication. Are we actually using strong authentication or not? Maybe we should go through and see if we could do some brute force attacks, or run through a dictionary file and see if we could break in that way. Attempt to guess login credentials. Maybe we could escalate our privileges with trying to work our way up from a regular user to a more powerful user. Perhaps we could add multi-factor authentication, which would be simply using something like a smart card with maybe a number. Put some things together. A smart card could produce a number and then put in a user ID with that, or a biometric, like read your finger, or a retinal scan or iris scan, something physical with maybe something you remember. But the idea is to get away from just one factor. One factor would be just biometrics or just a username and a password. That would not be sufficient. And of course, if people are trying to brute force their way through, would our software lock them out? Or perhaps maybe the policy would lock them out. Are there account lockouts being used and enforced? And what's the process for unlocking the account? Logging. We would hope that we have some logging that logs attempts of users to get into our system, intrusion detection. Maybe our logging is centralized or not. Of course, we could set it up to be centralized. What actually is getting logged? There's even other issues you run into with websites like cross-site scripting, which is to this day still a big issue. Another thing, error and exception handling. Many times software, when it has a failure, it will reveal way too much information to the hacker or to the one who's experiencing the error. What happens, a hacker knows that they can actually throw garbage information, you might say, garbage data into a program, and even though the program will not give them any information, will not actually go forward and reveal specifically what you would think they'd be looking for, it still could come back and reveal information about your software. Maybe it's a database. It could reveal information about your fields, the names that you're using, in product ID, product name, product price. It could come back with all kinds of information. These detailed error messages could help the hacker understand how your database is structured, for example. Therefore, they can essentially enumerate and extract that information. So what it comes down to is when our programs experience an error, we do not want them to spill out all the details to help the hacker along. And that's the concern with error and exception handling. So ensure that all sensitive operations are wrapped appropriately. You have to think of your methods to protect your information, whether you're using databases, and of course if you're going to use any sort of encryption. It's also a really good idea to check your software, your secure code, and see if it really is secure, and see if it's using any sort of validation, validating what information is being typed in, as in, is it the right format? Is it the right length? Does it make sense? If I'm asking for your zip code, I don't need letters. If I'm asking for your phone number, I don't need letters. But then I don't necessarily need numbers for your state. That doesn't make sense either. So it needs to be the right type of data. It doesn't need to be beyond a certain length, which correlates mostly to buffer overflows. Data should be validated before you construct SQL statements. There's a big one with input validation secure code dealing with SQL, structured query language. And watching out for characters that look like something could be building a malicious script. So the idea of your secure code review is to try to use this to help find out what the problems are, fix the issues. We may need to document and rank the issues, figure out, what we have here, what time we can put into this, is there anything we can do about it? Any better security practices we can put in place? Are we following policies? On and on. We can also use automated tools to assist, but not be the end-all, to assist us in finding security issues that we may have. They don't normally find complex issues, but they can still assist us. We could have flaws in our encryption. So really, using a combination would be the way to go. The automated could catch some things. The manual methods could catch some things. We're looking for the low-hanging fruit with the automated tool. For complex issues, it may require a manual review. Prevention, we have to think about the culture. It's true, change the culture. When you're thinking of the software development process, we wish to integrate security into this. We want people to think when they're developing software that it must be built with security in mind, not just functionality. We need to educate both the developer and the end user. We have to think about the possibilities out there, what could harm us. Patches to the operating system, very, very important. Although that can affect your code, your software package that you put together. Security testing, that's why you hear companies do vulnerability assessments and penetration testing, because they want to test out, see if there is any vulnerabilities in our software, whether it be Windows or some proprietary software that we have. We could put together a checklist of some sort. And again, the big topic here, I think, is input validation. When we ask for input, we verify that input before we pass it on to another part of our software. So in this chapter, we've learned about buffer overflows, looked at overflow illustrations, secure code review process, and some general prevention techniques. It's really about changing, I guess, the programmers, the culture, teaching us differently than we were taught 20 years ago. We need to think about security from the very beginning, not as an afterthought in the end.